Hello guys, welcome to my channel today. So today we want to talk about solving exponential functions. What do we do when we have an exponential problem to solve? All right, so let's start from the beginning. If you have, for example, 2 to the power x is equal to 70, what you want to do is to take the log of both sides, okay? So we can take the log of both sides. So log 2 to the power x is equal to log 70. All right. Then the next thing you want to do is to apply the third law, the exponential law of logarithm over here. That means that you are going to get x log 2 is equal to log 70. Then you divide both sides by log 2. So x is equal to log 70 over log 2. Right. Then you put the argument on the calculator and let's see what the calculator tells us. So we have log 70 over log 2. What the calculator tells me that the answer is 6.129 something, but the point is that we are using 3 significant figures, so we are just going to round it to 3 significant figures. Okay, that is what Cambridge will look for, so that's exactly what you want to give Cambridge. All right, now let's move on to the next question. So right now we have 7 to the power x minus 5 is equal to 40. Well, you want to do the same plan here. All right, take the log of both sides. So that means that you have log 7 to the power x minus 5 is equal to log 40. So this will give you x minus 5 log 7 is equal to log 40. You divide, so you have x minus 5 is equal to log 40 over log 7. Move the 5 to the other side, so you have 5 plus log 40 over log 7. All right, now what will the calculator tell us? So you have 5 plus, put the whole thing on the calculator to be free. So 5 plus log 40 over log 7. And the calculator tells us that our answer is 6.90. Okay, 3 significant figures. So that is the plan. Now let's look at this third example. Right, so let's solve this. It says, so we just have to take log of both sides, okay, like we've been doing. That means we have log 3 to the power 4 minus 5x is equal to log 2 to the power x plus 4, okay? So now we have 4 minus 5x, all right? Log 3 is equal to x plus 4 log 2, all right? Then you want to expand the bracket. You want x, therefore expand the bracket. You have 4 log 3 minus 5x log 3 is equal to x log 2 plus 4 log 2. All right, now the next thing you want to do is to group the x, and then so that means you have 4 log 3 minus 4 log 2 is equal to x log 2 plus 5x log 3. Now I just have to factor the x out on my right hand side, so that is exactly what we are going to do. So when we factor x out, we have log 2 plus 5 log 3. So that means that x is actually equal to, we have 4 log 3 minus 4 log 2 divided by log 2 plus 5 log 3. Right, so now let's put this whole thing on the calculator. And when we do that, the calculator says the answer is 0.262. All right, so that is the correct answer. All right, how about when you see a question like this particular one? 5 to the power x minus 5 to the power x plus 2 and plus 125. Well, this one you can't just take the log of both sides like what we've been doing. However, watch me do something here and I will explain every step of the way. First, you keep this 5 to the power x. However, you know that 2 to the power x plus 2 means 5 to the power x times 5 squared, right? Okay, then you have plus 125 is equal to 0. All right, now the next thing I want you to do is to expand that 5 to the power 2, that's 25. So you have 5 to the power x minus 25 times 5 to the power x plus 125 equals 0. All right, so now at this stage, what I want you to do is to use a variable substitution. Say, let y be equal to x to the power 5. So that would mean that you have y minus 25y, okay, is plus 125 is equal to 0. All right, so now this should definitely give you what that should give you negative 24y, right, is equal to negative 125. I just moved it to the other side. You divide through by negative, okay, 24. So you have y is equal to 125 over 24. Okay, you hold it. You are still looking for the value of what? Of x, not, you are solving for x, not for y, okay? So once you have something like this, you can just, see that but y is equal to 5 to the power x, okay? So now you can say 5 to the power x is equal to 125 over 24. I know that some of you might be thinking, well, why don't we just write a decimal? Well, a decimal wouldn't be the most accurate value. That's why I'm still keeping the 125 over 24. So at this stage, you can then take the log of both sides. Okay, so you have log 5 to the power x is equal to log of 125 over 24, giving us x is equal to, I'm jumping a step, sorry. X log 5 is equal to log 125 over 24. So now we have x is equal to log 125 over 24 all over log 5. Let's put everything on the calculator. So on the calculator we have log 125 over 24 divided by log 5. Calculator says our answer is 1.03, correct to 3SF. All right, now the same thinking is what we are going to apply to the question E right now. Okay, question E. But something beautiful is going to happen. All right, check this thing out. If I have 2 to the power 2x minus 2 to the power 2x minus 20 is equal to 0. What can happen right now is that I can also write 2 to the power 2x as 2 to the power x all to the power 2, right? Yes, it's allowed. And I have this guy here. I have this guy is equal to 0. So at this point, I can do the variable substitution by saying that let maybe k be equal to 2 to the power x, right? Once I do that, I can have k squared minus k minus 20 is equal to 0. Is it allowed? Yeah, it is definitely allowed. Now, this is a normal quadratic that all of us are aware of. If you are an ADMA student at this stage, and I believe that you can solve a quadratic. But if for some reason you cannot solve a quadratic, then I would encourage you to watch my video on how to simplify a quadratic, okay? Whether you want to factorize it, whichever approach that you want to use, you'll be fine with it. Okay, so now the factors that we are going to use will be k minus 5 and then k plus 4 equal to 0. That'll give us k minus 5 is equal to 0, or k plus 4 is equal to 0, giving us k is equal to 5 or k is equal to negative 4, right? But we are not done. Okay, the question didn't come with k's, we brought the k, right? So now you bring in but, okay, 2 to the power x is equal to k. Right, let's work with the first case. All right, the first case. So we have 2 to the power x is equal to 5 because we found the first k to be 5, right? Then you take the log of both sides. So log 2 to the power x is equal to log 5. So you have x log 2 is equal to log 5. That means that x is log 5 over log 2. Let's put this on the calculator and see what happens. Log 5 over log 2. Calculator says our answer is 2.32. Okay, then you take the second case where you have 2 to the power x is now equal to negative 4. All right, now there's no solution to this problem because there's no value of x that when you input there, your final answer is going to be negative. So you can just say that no real solution. All right, so you just end here. So this is how we solve this particular question. When you see it, just apply your indices, especially this point. Your indices is very, very important. If you're able to express it in this way, then you do your variable substitution. Once you find the two values of whether if you use y, then you get two values of y. If you use k, two values of k. Once you find it, don't be quick to say, well, I'm done with the solution. You are not done because you brought in this particular value. So you must now bring the assertion that you made earlier, okay, and then you find the value of x. All right, now we are going to apply the same thinking to question number F. All right, now question F, there's one thing that we need to do, because if you look at this question F, you have 2 to the power x, but now you have 4 to the power x. You should quickly see that you can make 4 to the power x look like 2 to the power something, okay, so that it would be in uniform, in agreement with what you have there. All right, so 4 itself is 2 to the power 2, all right? So 4 to the power 2x is 2 to the power 2 all to the power x, all right? Minus 3, 2 to the power x minus 10 is equal to 0. All right, now you can have 2 to the power 2x minus 2 to the power x minus 10 equals 0. Then we can do our variable substitution at this stage. All right, so we can say that let y be equal to 2 to the power x. Now, if y is equal to 2 to the power x, then this part will give us y squared, okay? So we have y squared, all right, minus 3y minus 10 equals 0. All right, so if you have such a case, you'll be wondering, how do I solve it? Well, look for factors of negative 10 when added gives us negative 3, okay? Is it possible though? I don't think it is possible. No, I don't think so. Let's see. Have we made any mistake? Is there a problem with the question? Have we made a mistake? Let's Okay, this is 4 to the power x minus 3 to the power 2x minus 10 equals 0. Okay, we made a 4 2 to the power 2x, which is correct, giving us y squared. Then 3y minus 10 equals 0. All right, so 10, right? Negative 10, factors of negative 10, that is negative 5 and 2. I think we are correct. All right, so let's use that. So we have y minus 5, and then y plus 2 is equal to 0, right? Okay. All right, so we have y minus 5 is equal to 0, or y plus 2 is equal to 0, giving us y is equal to 5, or y is equal to negative 2. All right, good, but we are not done. Don't be quick to say you are done. So let's just say that but y is equal to 2 to the power x. Therefore, let's take the first case where we have this. In fact, the negative isn't going to work because 2 to the power nothing will give you negative 2. Okay, so let's just take this part and work it out with. So you have 2 to the power x is equal to 5. You take the log of both sides, so you have log 2 to the power x is equal to log 5. So x log 2 is equal to log 5. You divide, so you have log 5 over log 2, and then we can put it on our calculator to see what the calculator gives us. Okay, so calculator, log 5 over log 2. Calculator says x is definitely 2.32. Okay, and then we are done. So that is basically how to approach questions of this particular form. All right, so whenever you are given an exponential question like these, please take your time. It's easy to take log of both sides, but if you have to do small indices before you take log of both sides, that's also allowed. All right, in our next video we'll be talking about the change of base of logarithm, okay, and how we use change of base to solve logarithmic equations. Right, so till we meet again, stay safe.